This is a show where we take our matter and we change it. We're going to take a look at our three states of matter, and then we're going to see how we can mess around with it during the show. Now, the first thing I want to do, though, is talk about gas, because solids and liquids are very easy to point out. This thing? Tea kettle. Do you think this is a liquid or a solid? How about the table it's sitting on? How about this sign? All right, so we're very good at recognizing solids. They are things that keep their shape, they have some form or structure to them. Even though my sleeve and my skin are two things that are very flexible, they are still solid objects. They still have some form or structure. Because if we want a liquid, next we would need something that flows and splashes and sprays and takes the shape of its container, like soapy water, juice, coffee, fun stuff like that. But gas is what we have a hard time experiencing, because we're breathing it and you can feel it if you go like this. But you can't see it, even though it's taking up most of the space in this room right now. So let's talk about what makes up the air we're breathing. Okay, air is made of a bunch of gases, not just one. What's an important one that is keeping you alive?
Oxygen.
Oxygen, right? Super important. You are breathing oxygen gas that is keeping your human body going. But the air you're breathing, do you think it's mostly oxygen? No. Oxygen's great. But you don't want too much, because oxygen is also very good at keeping something else alive. Yeah. For this fire to burn, there are three things that we need. We need fuel, like the candle or the match, heat, which we get from friction or fire, and an oxidizer, like the oxygen we breathe. If there is no oxygen around us, we get no fire. We also can't breathe. But if we have a lot of oxygen, we get a more intense fire. So imagine this situation. I walk into a room where we have nothing but oxygen, and I decide that I'm going to light a match. Do you think that's safe for me? No, I would explode. I would burst into flames. It would be super unsafe for me, which we don't want. We don't want that. So that's why oxygen, we're very happy with it taking up about 21% of the air we breathe. That's good for us. That's what we need. Boom. So that means that there must be more stuff in the air around us. One of the gases that we have will make bubbles and balloons do this. Helium, right? Helium is a gas that will make balloons float away. Now, helium is something we can find at our birthday parties, makes those balloons float, but helium is not something we can blow up here on the stage. So we also have another gas called hydrogen. Hydrogen is extremely flammable. So both hydrogen and helium are lighter than air, and they are in our air as well, along with other gases like carbon dioxide, water vapor, and argon. But all of these gases make up about 1% of air. So, along with our oxygen, our hydrogen, our helium, water vapor, carbon dioxide, and argon, we definitely don't have enough in our air to do that. All this stuff makes up only less than a quarter, less than a fourth of what we're breathing. So most of our air is just one single gas. You can't see it, smell it, taste it. It's not poisoning you, but it's not keeping you alive, and it's not flammable. It is a boring gas. Does anyone know the name of this boring gas? It starts with the letter N. Nitrogen, yes. So most of our air is made of something called nitrogen. And it's kind of just like a filler. I mean, it's not keeping us alive, but it's not really doing anything bad. It's just there. So nitrogen gas is not something we think about very often. What I want to do next, though, is take our nitrogen gas and turn it into a liquid. We're going to take nitrogen and then experience liquid nitrogen. Now, who has heard of liquid nitrogen? Okay, if you've heard of liquid nitrogen, you may notice that I've just put my goggles on, and I'm going to put on some gloves, which means this stuff might be a little more dangerous. In fact, if you've heard of liquid nitrogen, there's probably one big thing you've learned about it. One thing that you've learned about it. What do you know about it? It freezes things. If you've heard of liquid nitrogen, have you heard that it's cold? Yeah, so that's one thing we hear about when we first learn about liquid nitrogen, that it's very cold. So let's see if we can just look at this and use our powers of observation, our eyeballs, to see how cold it is. Okay, so here's our very cold liquid nitrogen. We are going to use it to mess around with our states of matter and move between them. Now, we can see a lot of steam or vapor here. Can you see it bubbling in there?
Yeah.
Yeah. So that is a characteristic of cold stuff. When you see a liquid bubble and steam, we know that it's cold. Is that right? No, right? If you make water bubble and steam, what are you actually doing to it?
Heating it up.
Heating it up. If you boil water on a stove at home, at a kettle, anything like that, you're going to watch it bubble and steam because it's going from liquid to gas. So one problem we have right now is even though we've heard liquid nitrogen is cold, we can't prove it yet because our eyesight, our human vision is not great at determining temperature. So we're going to have to use another tool. Not my finger. Because while that is a good tool for telling temperature, probably not the best way for me to do that, okay? So we're going to use a thermometer to see if this